Mechanisms that explain the distribution of the impact of climate change across the world have policy implications. Vulnerability to climate change is a function of exposure and adaptive capacity, and in turn these are functions of development. The implication is that future vulnerability will be very different from current vulnerability. But the question is how. There's two big uncertainties there. First, we don't know future economic growth yet. And second, we don't fully understand the relationship between development and vulnerability. I can talk about these things in theory, in abstract terms, but I will instead take a particular example, namely malaria. You're looking at a map of the world. The colors indicate the change in the risk of malaria due to climate change. In the yellows, you're looking at increases of malaria risk of up to 50%. And in the reds of up to 100%. That's a doubling of malaria risk. In purple, you're looking at areas where malaria will be introduced where it's currently not. And then there's also some green, that is where the risk of malaria will decrease. And there's three reasons for this pattern. First, if it's warmer, then the malaria parasite grows faster. Second, if it's warmer, then the vector of the disease, the mosquito, is more active. And third, the mosquito needs warm, still standing water to breed. So in a warmer, wetter world, you would expect to see more malaria. This is a different map of the world with 5 colors, and the key question is, what is the difference between red and yellow? In red, you're looking at those areas where there is malaria. In yellow, you're looking at those parts of the world where there could be malaria, but there isn't. And then the blue and the green and the white areas, there can't be malaria because it's too cold or too dry or both. The key difference is, the key question is, why is there no malaria in the yellow areas? And the answer to that question is not climate. William the Silent suffered from the other-day fever, that is malaria. George Washington did not want Washington DC to be built on the shores of the Potomac because of the malaria risk. There have been reported malaria outbreaks as far north as Stockholm and Murmansk. So climate is not the answer. The answer is income, and there are 3 mechanisms. In its life cycle, the malaria parasite needs to spend time in its human host as well as in its mosquito host. If you take malaria medicine, that has 2 effects. It prevents you from becoming worse, to becoming more ill, also prevents you from dying, but it also stops you from being contagious. So if enough people in an area take malaria medicine when they fall ill, the parasite goes extinct locally. That's one reason. The second reason is that mosquitoes need warm, still standing water to breed. So if you put proper roofs on your houses, if you put tarmac on your roads, if you drain wetlands, then you reduce the habitat of the mosquito and you reduce the malaria risk. That's the second reason. The third reason is clouds of DDT. After World War II, we sprayed large amounts of DDT in malarious areas to clear the disease from the southern United States, from southern Italy, places like that. And it was very effective. You killed billions upon billions of mosquitoes. Then just as these programs started moving into South America and into Africa, Rachel Carson had written her book Silent Spring, and that led eventually to a ban on DDT. And that stopped the spraying program, and that is one of the reasons that there's still malaria in South America and in Africa. DDT has since been re-allowed in small quantities to impregnate bed nets, but the reason that there is no malaria in the southern United States and in southern Europe is to a large extent due to this spraying program in the 40s and the 50s and the 60s. Let's now put these 2 maps together in a scenario study, and this is work from the late 1990s. On the horizontal axis, you're looking at time. When the study was written, 2000 was in the future. On the vertical axis, you're looking at the number of people dying per year because of climate change-induced malaria. In black, you're looking at the scenario where climate is the only thing that changes. And the implication of this is that the current death toll of 70,000 people dying each year because of climate change-induced malaria, that number increases to more than 200,000 by the end of the century. This is when climate is the only thing that changes. The dotted lines that you see here indicate the uncertainty about the malaria model. Second scenario that you see is that population also changes. Not just climate changes, but population grows as well. And because malaria is concentrated in Africa, what matters is population growth in Africa, which is much stronger than elsewhere in the world. And as a result, the number of people dying because of climate change-induced malaria increases to 750,000 per year. That is a lot of people, but not nearly as much as the number of people dying, say, of indoor air pollution. But still, 750,000 is 750,000 too many. Now, this looks at the effects of climate and looks at the effect of population growth. But I just showed you a map and argued that rich people don't die of no malaria. If we add that to the picture, we end up with the red line. And essentially, the assumption here is that as people grow richer, as countries grow richer, they get better at providing medical care, get better at environmental management, and perhaps use more pesticides to kill the mosquito. And as a result, in this particular parameterization, in this particular scenario, the disease disappears around the year 2085. Now, this assumes a particular income elasticity of healthcare as a function of per capita income. That income elasticity is estimated for the world as a whole, but you could also say, well, let's estimate it for communist countries only, because communist countries tend to spend more on public health care than non-communist countries with a comparable income. And if you impose that particular income elasticity, you end up in this curve here, and the pattern is the same, but the disease disappears much, much more quickly. You can also argue, actually, malaria is mostly concentrated in Africa, so perhaps we should estimate this income elasticity for African countries only. And then you end up with this purple line, and the pattern is the same. There's still climate change and population growth pushing the numbers up, and there's economic growth pushing the numbers down, but the effect of the latter is much, much delayed. So there's a lot of uncertainty about what this income elasticity would be. But the qualitative pattern is the same. Now, as I said, this study was done in the late 1990s, and in the late 1990s there was this crazy man called Bill Gates, and Gates said, we can't develop a malaria vaccine. And at that time everybody thought he was nuts, because all the experts said this is way too complicated. But Gates insisted, put a lot of money into it, and we thought, let's just put this in the scenario analysis. And at that time, the announcement was that the malaria vaccine would be ready by the year 2020. It took 20 years to roll out the polio vaccine across the world. So that is the scenario that you see here. Vaccine is developed by the year 2020, and by 2040, everybody has been vaccinated, and the disease disappears. And this tells you something about just all the moving parts that you need if you want to project the impact of climate change. You do not just need to know how much climate change there will be and how the disease will respond. You also need to project population growth. You need to project economic growth and its relationship with the thing in question, namely public health care. And you also need to take into account advances in medical technology. Now, when Bill Gates announced this, people thought he was nuts. It was impossible, that was the mainstream thought, it was impossible to develop a malaria vaccine. The disease was too complicated. And this scenario that you see here was essentially dismissed as science fiction. In reality, the vaccine was actually ready by the year 2017 and is now being rolled out across the world. And this tells you also something about the complications of scenario development. There's another thing that took us by surprise when we wrote these scenarios, and that is that if you look at the initial period, things are getting worse. This is what really happened. These are the data. On the horizontal axis we have time from 1990 to the year 2017. On the vertical axis we have the number of estimated malaria deaths by region. The scenario analysis essentially took this trend and extrapolated it, but things changed here around 2003 or so. And what changed was that there was a big program to push bed nets into poor households, particularly in Africa, and the re-allowance of DDT. So the DDT was sprayed on the bed nets to kill the mosquitoes, and that completely changed the picture. And this was not in the scenario analysis. By the way, the main driver of this program was George Bush. We associate George Bush with 9/11 and the Iraq wars, and we don't have a particularly fond memory of him. Had 9/11 not happened, then we would have recalled George Bush, who was a bit of a bumbling fool, but did do a lot of good, and he may well have won the Nobel Prize for Peace. Now, what are the implications for policy of all this? And for this, I'm going to talk about the Schelling Conjecture. The Schelling Conjecture is named after Tom Schelling, who won the Nobel Prize. And he was a bit of a naughty man. In the early 90s, he worked a lot on climate change and climate policy. And he asked two pertinent questions. The first was that Schelling noted that most greenhouse gas emissions come from rich countries, but most impacts of climate change fall on poor countries. So that means that if you express a concern about climate change, if you say I'm worried about climate change and we should do something about it, then essentially you're expressing a concern for the well-being of the children and grandchildren of the currently poor people. And that is very strange, because if you look at our behavior, we don't seem to care much about these people. So why do we care about their grandchildren? If you look at our trade policy, if you look at our military policy, if you look at our immigration policy, then that really suggests that we don't care much about the people from Congo or Bangladesh. But we care about the grandchildren of the people of Congo and Bangladesh. That is very strange. Now, this is a rhetorical question, and there's no good answer to it. But Schelling asked the second question, and that is, let's suspend our disbelief for a moment, and we do care about the future inhabitants of poor countries. How can we best help them? Is greenhouse gas emission reduction the best way to reduce their impact of climate change, or are there other means of doing so? Or more prosaically, is adaptation assistance a better way to reduce the impact of climate change than greenhouse gas emission reduction? Now, this is an important question to ask, but it's a difficult question to answer. If you are sure that you can spend money on developing a malaria vaccine and it will be successful, then yes, this is a very good way of reducing vulnerability to climate change, and you get a much bigger bang for your buck in doing so than if you were to spend the same amount of money on greenhouse gas emission reduction. But this is true in retrospect. As I said, in prospect, people thought that Bill Gates was nuts. They were happy to take his money for research, but they actually thought he had very little chance of success. But if you can be sure that throwing money at a problem will resolve a situation, that if you throw money at a problem, then you will come up with a technological solution that helps reduce the vulnerability to climate change, then by all means, this is probably a better way of reducing vulnerability to climate change and reducing the impact of climate change. Now, that is true in retrospect for something like a malaria vaccine. I also talked extensively about why Bangladesh is so vulnerable to climate change and to sea level rise. And that, I argued, had more to do with governance, corruption, lack of political will, lack of political care for the people in a country. And that is the sort of problem where throwing money at it is probably not going to help much. In fact, if you throw money at a country like Bangladesh, then that money will simply end up in luxury condos in London and in Swiss bank accounts, rather than that it helps the people of Bangladesh protect themselves against floods. Adaptive capacity is closely related to development, so the Schelling program to reduce vulnerability to climate change is very much a program in development assistance. We now have some 70 years of experience with development assistance with decidedly mixed results. So here is another example. This is the yield gap. So the yield gap is the difference between what an average farmer gets of his fields versus what a model farm gets of the fields. In many places in the world, there are so-called model farms that work on the actual soil and the actual climate, the same soil and climate that other farmers work, but use the latest seeds and the latest irrigation technology and the latest pesticides. And the yield gap measures how far is the average farmer from the model farm, from the technological frontier at that particular moment. And if you look at Europe, for instance, then you see that farmers are pretty close to the technological frontier. They get as much of their fields, get as much out of their fields as is possible. But if you focus on West Africa, then the yield gap is much larger. Farmers get only half or sometimes only 10% of what you can get on a model farm. And this is a big gap, and this matters. This also matters for climate change. If you recall the discussion about the impact of climate change in agriculture, and sort of the worst case numbers that you saw were that climate change would halve the output of a farm. Now, if you can bring these farmers to the technological frontier, then they would actually, in some cases, increase their output by a factor 10. So even if climate change then takes away half, then they're still 5 times better off. So here you also see, well, potentially the Schelling conjecture holds. Potentially, if we bring these farmers up to the technological frontier, then a lot of the concerns about climate change will simply disappear. But also here, this yield gap has been known for decades, and it has also proven to be difficult to close it. The reasons have little to do with simple measures, but has everything to do with the complex way in which farmers interact with the authorities, for the land registry, for instance, and how farmers interact with both output markets, but also input markets, particularly capital markets. And it turns out that this is just a very difficult problem to crack. Potentially, the Schelling conjecture holds here, but getting it to work in practice is very difficult. Another thing that you should keep in mind, that even though it is in general true that poorer people are more vulnerable to climate change, there are local exceptions to this, and I list 3 here. The first is that parts of our concern about climate change are a luxury good. Richer people put higher values on health risks, put higher values on risks to nature, species extinction, and those sort of things. Richer people also tend to live longer, and that means they have more time to develop cardiovascular problems, and if you have a cardiovascular problem, you're more susceptible to heat stress. Finally, richer people might buy air conditioning to protect themselves against the heat, but of course air conditioning does not make the air cooler, it just moves the energy out of the building and makes the surroundings hotter. So the rich people inside their houses are fine, but the poorer people, definitely homeless people, actually are worse off. So it is not necessarily the case always that richer means less vulnerable. There are important exceptions to this rule.